So today we are doing the second part of indicator 5. The first part was tables of proportional relationships. The second part is graphs of proportional relationships. And what I'm going to go ahead and do, I am using my smartboard directly with the graphs already made. Even though in class we will actually make the graphs, but this is just to save us time while I am filming this. Okay, so um, let's look at our learning target. I can identify whether two quantities are proportional from table or graph. So the table part I've already done. And I can identify proportional and non-proportional um, quantities. Okay, so that is the learning target. So here is the lesson, just launching a lesson question. And it says if you have a job, your employer may pay you based on the number of hours you work. In this case, the total amount of money you earn is proportional to the total number of hours you worked. All right, so let's say you're getting $10 an hour. So for 1 hour, $10, 2 hours, $20, 3 hours, $30. So as you can see, a proportional ratio is being developed in that case. Okay, so um, and there we go. That's exactly what I was talking about. And this is the x-axis always. That's the y-axis. All right. Time. We have already done this in the past. Time is always the x-axis. All right. And so the amount of money that you're earning is dependent on the independent factor, which would be time. All right. So as you can see, we are going to put time over here, 0, 1, 2, 3, 4, 5, 6, whatever hours. And then you are going to graph for 1 hour, you have $10. 2 hours over here, $20. 3 hours, $30. Okay, 4 hours, $40. So as you can see how this line is going straight in this graph. And so we can definitely look at this graph and see if it is proportional or not. And so the constant of proportionality, we have talked about that yesterday. But when I look at the graphs of proportional relationships, all right, so if you look at this one, two quantities x and y are proportional when y is equal to kx, where k is a number which is in which k is not equal to 0. And the number k represents the multiplicative relationship between the quantities, and it is called the constant of proportionality. You can also write k is equal to y divided by x. So, this point divided by the x part. Okay, so y divided by x will also give you that proportionality, and we are going to discuss that in a minute. All right, so let's look at these graphs. And how can you determine if a relationship is proportional from a graph? So if I'm looking at this graph and I'm looking at that graph, I know this is proportional. First and foremost, for your graph to be proportional, it has got to pass through the origin. And origin means what? Where the ordered pair is 0, 0. Okay, so is this passing through 0, 0? Yes. Okay, and then the graph has to be a straight line. Okay, so yes, this is also a straight line and it's passing through the origin. So this one is a proportional graph. All right, the relationship is proportional between y and x. All right, let's look at this one. Even though it is a straight line, since this graph is not passing through the origin, which would be 0, 0, which would be down here. Okay, since it's not here, it's starting up there. And so because of that, this is not a proportional relationship. So it's non-proportional. So that's what makes the big difference between proportional and non-proportional. All right. So let's look at this. Is the relationship over here proportional. So if I look at this graph, all right, so is it proportional? Yes. Is it starting at 0? So we have 0, 0, the ordered pair over here. It is at the origin and it is a straight line. All right. So this is a proportional relationship over here. Okay. Um, and then let's look at this one. So now same thing. It is not starting at the origin where the ordered pair should be 0, 0. It is starting above that. And that's what makes this non-proportional. Okay. Some more quick examples. So look, this one, even though it is starting at the origin, that line is definitely not a straight line. It's a curved line. So because of that, this is non-proportional. It has got to have the origin ordered pair, which is 0, 0, and be a straight line. Okay? So this is non-proportional. And then here is an example of proportional. Now see, it has all the qualities of being proportional. 0, 0 ordered pair starting at the origin, and it's a straight line. So that's the difference between a proportional and a non-proportional graph. Okay. So here are some more examples. If you are given a table like this, and you are asked, is there a proportional relationship between X and Y? So you have to take the table and you have to graph it. Okay, so if I look at the first one, I have X is 1, Y is -2. X is 2, okay, and Y is 0. X is 3 and Y is 2, okay. X is 4 and Y is also 4. So if I'm looking at this one, remember this becomes my ordered pair, the X and Y. This is 1, -2, okay. So that would be my ordered pair that I am going to graph. So if I had my ordered pairs here would be 1, -2, 2, 0, 3, 2, 4, 4. So this X and Y, because remember in an ordered pair, the first coordinate is always the X coordinate, the second is always the Y. So that's how we have plotted this. Okay, this is 1, this is -2. This is 2, this is 0. This is 3, 2. And then we have 4, 4. So as looking at this line, it is not passing. It should have passed here. It should have passed here for it to be proportional. But it is not passing this part because that part would be 0, 0. Okay? So it is not a proportional relationship. Okay? All right. So let's look at the other one. So again, my ordered pairs over here are 0, 0. I have 2, 2. I have X is 4, Y is 4, X is 6, Y is 6. All right. So let's see. Do we have the origin? Yes, here. Okay. Do we, then let's look at this. We have 2 and 2, which is here. We have 4 and 4, and we have 6 and 6. All right. So if I'm looking at this and I connect, all right, here. If I connect this, I can already see, yes, it is passing through the 0, 0 origin, and it is a straight line. So therefore, this is a proportional relationship between X and Y. Okay? So let's look at this one. Again, if I have the table, another way just to look at the table and to see if it's proportional, here are two examples that I can give you. All right. So when I look at the first ordered pair, okay, so if I look at the first ordered pair, what do I have? I have 0, 0. I have 3, 1. I have 6, 2, and I have 9, 3. Okay, these are my ordered pairs. So I know this is the origin. Okay, now let's look at the table. I can just look at the table and know whether it's going to be proportional or not, because my unit rate is going to be exactly the same. All right, so in this case, look, it's 3 over 1, right? 6 divided by 2 divided by 2, what do I get? 3 over 1. Okay, and then look at this one, divided by 3 divided by 3, I again get 3 over 1. So when I'm looking at that, my constant of proportionality is 3. Okay, so I can see that this one is definitely going to be a proportional graph, or it's a proportional relationship. I'm going to have the line go through the origin and it's going to be a straight line. Okay, let's look at this next one. All right, so I have 1, -1. I do not have 0, 0, which is required, because that's what for it to be proportional, it has to go through the 0, 0. Okay, so it is not. Then I have 2, 0, and I have 3, 1. So when I am looking at this, I have 4 divided by 2, I'm getting 2. 3 divided by, so if it's 3 over 1, this should have been 6 over 2, right? So, and then this also should have been proportional, but none of this is looking proportional. Just by looking at the table, you can understand if it is proportional or not, even before you make the graph. All right, so why does the line of a graph of a proportional relationship need to be a straight line and pass through the origin? Okay, so when a line on a graph is straight, it passes through the origin. It means the ratios between the x and the y values are constant. And if the line does not pass through the origin, then the ratios between the x and y values would not be maintained. Okay, so that's the reason. So the constant values of the ratio are if it's passing through the origin only, otherwise it's not going to be maintained. Okay, so here's an example. A rabbit challenges a tortoise to a race. The table shows the distance that the tortoise moved after 0, 1, 2, and 3 minutes. Determine whether the number of feet the tortoise moves is proportional to the number of minutes by graphing the relationship on the coordinate plane. But even before I graph it, okay, let's look at these ratios. Okay, so I have distance 0, 0. So this ordered pair, all right, this ordered pair is telling me that we have the line passing through the origin, and we definitely need that. Okay, then I have the ordered pair. I have x and y, which is 1 and 6 over here. All right, and then I have 2 and 12, and then I have 3 and 18. If I'm looking at this and I am finding the constant, and remember the constant, which is k, is also equal to y over x. Okay, so if I do y over x, of course this is the origin. So here, y over x, I get 6, right? 6 over 1 in simplest form. 12 over 2, again I get 6 over 1. 18 over 3, I again get 6 over 1. So just by looking at that, I can already see that the constant of proportionality is 6. All right, and so for all of them, I'm getting the exact same unit rate, and it is starting at the origin. So this is going to be a proportional graph, okay, or it's going to be a straight line. So here you go. So we are going to take these, and I already told you that you're taking your ordered pairs like that, okay? And then here, see, when I graph it, remember your x over there is going to be your time in minutes, and then y is going to be the distance. All right, and so look how it is going through the origin, which would be here. And then for 1, I have 6. Okay. For 2, I have 12. And for 3, I have 18. And so on. So it is going in a proportional manner, and that shows a proportional relationship. Okay. So relationship is proportional because the line is straight and it passes through the origin. Okay. And then we've already talked about if the graph of a proportional relationship must be a straight line through the origin, how does the table illustrate that same information? And I had already talked to you about how I can use the table and find the unit rate of each of the values. And if that is exactly the same, it is proportional. All right. And of course, I'm going to have the ordered pair of 0, 0 to begin with. Okay. So here's another one. The cost of the 3D tickets is 12 for 1, 24 for 2, 36 for 3. So if I'm making a table and I do y over x, 12 over 1, okay, 24 over 2 is 12 over 1. 36 over 3 is also 12 over 1. So as you can see, in the simplest forms, they have exactly the same unit rate. Okay. And so when I'm trying to find that proportional uh, of, constant of proportionality, it's going to be 12. And so look, it starts at 0. And then here is the first one. Okay. And so x over here, and then for 2 I have 24. I can see this one here. Okay. And for 3, as you can see on the graph, I have 36. All right. So yeah, definitely straight line, and it is proportional. Okay. Because the graph is a straight line and is passing through the origin. Okay. Let's look at this one now. Okay. A rabbit challenges a tortoise to a race. The table shows the distance that the rabbit moved after 0, 1, 2, and 3 minutes. So 0, and then, you have in 1 minute 8 feet, 2 minutes, you still have 8 feet, and then in 3 minutes is 15 feet. So if I'm looking at the table, there is no proportionality here. Because 0 and 0 is 8 divided by 1, that's the simplest form. 8 divided by 2, that gives me 4, not 8 over 1. 15 divided by 3, that's going to give me 5 over 1. Okay, so it's all over the place. It is not proportional to the same value, which would be 8 over 1, like we started with in the beginning. Okay, so just looking at that, I know that this graph is going to be non-proportional. And so if I had to, here again, my ordered pairs, I have X, Y, 0, 0, 1, 8, 2, 8, 3, 15 are my ordered pairs when I start graphing this. And here, look at the graph. It may begin at the origin, but look what's happening, going up and then this way and then up. You can't have a graph like that telling you it's proportional. It's got to be a straight line. Okay, so this graph is not proportional. All right. Is there another way to determine if the relationship is proportional or non-proportional? And we have already talked about converting every the xy factor, so the y over x in the table to the simplest form, which would be the unit rate. And if they all have the same unit rate, it's going to be proportional. If they have different unit rates, it is not going to be proportional. Okay, so here's one more example. The table shows the number of calories an athlete burns per minute of exercise. Okay, so is this going to be proportional? Let's see. We have 0, 0, 4 over 1 simplest form, because this is xy, right? Ordered pairs are 0, 0, 1, 4, 2, 8, and 5, 10. 8 divided by 2, yeah, you do get 4 over 1. But 10 divided by 5 is definitely not going to give me 4 over 1. That is 2 over 1. So looking at that, I can already see that this is non-proportional. Okay, so look, it started off fine and then it went like this. And so that is, this whole line is definitely, it's not a straight line. So this is going to be non-proportional. All right, it is going through the origin, but it is not a straight line. Okay, to find the constant of proportionality from graphs, what you need to do is you can determine the constant of proportionality using the coordinates of any point on the line other than the origin. Okay, and the constant of proportionality, we've talked about that, is the ratio of y over x for any point on the line except 0, 0 when x is equal to 1. So if I look at this one, all right, we're not going to look at this one. So 5 over 1, that is the simplest form. Okay, let's look at what happens with 2. We have 10 over 2. What is 10 divided by 2? I still get 5 over 1. Okay, 15 divided by 3 gives me 5 over 1. 20 divided by 4 gives me 5 over 1. So as you can see that everything in the simplest form with the y over x, the unit rate is going to have the same value. In this case, the unit rate is going to be of the distance, which is 5 meters in 1 second. And that's what I'm getting as the unit rate. Okay, so therefore this is going to be proportional. X and y are proportional in this case. All right, so let's look at this one here. Okay, let's see what is, we are going to find the constant of proportionality from the graphs. So same thing, we had 5 over 1, 10 over 2, 15 over 3. So what am I noticing? That the distance over there, it's 5 meters in 1 second, and the difference between each y coordinate from one point to the next on the graph is equal to the constant of proportionality. Okay, so you can see this is the difference, which would be 5. Okay, so because look, 5, 10, 15, 20, 25. So that's what it means. Difference between each y coordinate from one point to the next on a graph is equal to the constant of proportionality. So here the constant of proportionality is 5. Okay, let's look at this one. In a 100-meter race, assuming the runner's rate is constant, the distance run is proportional to the time spent running. One runner's data are shown on the graph. Find the constant of proportionality and describe what it means. So first and foremost, we are going to look at, okay, what do we have over here? Okay, so here are my x and y. All right, if x is 5, y is 30. Okay, so I'm just going to, either you can make a table or you can write your ordered pairs. Okay, so if I put my ordered pairs, I have x is 5 and y is, see here, y is going to be 30. All right, next one, if x is 10, here, I wonder if this is a little bit higher. There we go. If x, let me see, and then I have 15. Actually, this is 31. Okay, and this one is 10 and it's 62. And then we have 15 and this is 93. Okay, 15 and 93. All right, this could be a little misleading because a little bit above the 30. All right, so here are my ordered pairs first. Okay, and then I'm going to look at, am I going to get exactly the same unit rate for all of them? Okay, so we are going to go ahead, and I just want to show that to you. So look, first, oh yes, see, it was a little bit higher. Okay, so it looked a little bit, yeah, this is more accurate. So it is a little bit higher. So you're going to complete the ratios, y over x. And so as I told you earlier, uh, so look, this is 31 over 5, and then we had 62 for 10, and then we have over here 93, so 15 and 93. Okay, so to find the constant or proportionality, first you do the simplest form. You're going to divide each by the x, y by x. 31 divided by 5, 62 divided by 10, and 93 divided by 15. And then you'll see, am I getting exactly the same answer on all three cases or not? Okay, and if you do, yes you do, you get 6 and 2/10, and that is your constant of proportionality over here, because that's the gap between the y coordinates. Okay, now based on this constant proportionality, we know that it keeps increasing by 6 and 2/10. How far will the runner travel after 20 seconds? So all you do, we know that 6 and 2/10 for one, etc. And that's the rate we have. So we would just multiply with 20 in this case. Okay. And then we would get 124 meters. And that's what the distance would be. Okay. All right. So here's another extra example. So let's look at these numbers. All right. And we are going to find the constant of proportionality over here. So as I can see, it's going up. This is 0, 0. This is 1 and 15, 2 and 30, 3 and 45, 4 and 60. So we can see that the gap over here in between is 15. And that is my constant of proportionality, okay? In simplest form, each of those, whether I divide 15 by 1, it's already in simplest form. I divide 30 by 2, I get 15 over 1. I divide 45 by 3, I am going to get again 15 over 1. If I do 60 by 4, I am going to get 15 over 1. So my unit rate is 15 feet over 1 second. Okay, and my constant of proportionality, that is the gap between these number, between the y coordinates, is going to be 15 over here. Okay, so 15 feet. All right, and then when we are analyzing points on a graph, two quantities are proportional. You can use a graph to find the constant of proportionality and to do the interpretation of the points which are 0, 0 over here. Okay, so let's learn how to analyze points. What is the significance of 0, 0 on the graph of a proportional relationship? Okay, so if we talk about this, we know the graph of any proportional relationship will pass through the origin. So that's what the biggest thing to remember for a proportional relationship is. And then if I'm analyzing points, the number of students on a school trip is proportional to the number of teachers as shown in the graph. The line representing the relationship is a dashed line because the number of teachers can only be a whole number. Obviously, you can't have a half of a human being, right? Or 1/4 of it. It's got to be a whole. So that is why it can only be a whole number. What do the points 0, 0 and 125 represent? All right, so if I'm looking at this, I know that there are 25 students for one teacher, 50 students for two teachers, 75 students for three teachers, 100 students for four teachers. So as you can see, it is definitely going to the origin. The constant of proportionality is 25. All right, and so we know that there are 25 students per teacher in this case. And so, yes, this is a proportional relationship. Okay. So here we go. And that's exactly the same thing. And it means 0 0 means for 0 teachers there are 0 students. Point 25 means that for 1 teacher there are 25 students. And we talked about the constant of proportionality is 25, and the unit rate is 25 students for every 1 teacher. Okay. Can you find the unit rate from any point on a graph that shows a proportional relationship? Explain your reasoning. All right. So definitely, when we divide the y by x, we are going to get unit rate. Okay. And so the ratio of y to x for any ordered pair is equivalent to the unit rate, which is the same as the constant of proportionality. Okay. And here's one, a last thing. Let's look at this one. So, Michelle and Angelo are participating in a school fundraiser. The number of items each student sells after 1, 2, and 3 days is shown in the table. Which ordered pair represents a unit rate for the number of items sold per day? Okay, so let's look at these. So if I look at this ordered pair, the top one for Michelle, we have 0 0, we have 1 3, we have 2 6, and we have 3 9, right? And then let's look at Angelo's. Angelo's X and Y, 0 0, 1 1, 2 4, okay? And then 3 5, 3 5. So let's look at what has the same unit rate. Okay. So remember, what is K? It's going to be Y divided by X. This is always X. This is always Y. X, Y. The first coordinate is always the X coordinate. Second coordinate is always the Y coordinate. So 3 divided by 1, what do I get? 3 over 1. 6 over 2, that gives me, divided by 2, that gives me 3 over 1. 9 divided by 3 again gives me 3 over 1. So therefore, this one over here, which ordered pair represents a unit rate? It would be this, right? 3 1, or 1 3, which x is 1 and y is 3, and that would be my unit rate. In this case, no, because you have 1 over 1, and then 4 divided by 2, you have 2 over 1, and then you have 5 over 3. So yeah, that is not proportional at all. Okay. So as we said, the solution for this one is the ordered pair, which is representing is 1 3. We talked about that. All right. How could you have determined that Angelo's graph was not proportional before graphing the relationship on the coordinate plane? Because whatever the items that was sold each day was not constant. So the graph could not be a straight line, okay, and could not be proportional. So anyways, so pretty simple lesson over here. For a graph to be proportional, the x and y relationship to be proportional, the graph has to pass through the origin, and it has to be a straight line. And then again, you can look at the unit rate, and you find that constant of proportionality by taking y coordinate and dividing it by the x coordinate. So y divided by x, and for all of the values in a proportional ratio, the unit rate is going to be exactly the same. So that ends our indicator 5, and this is identifying whether two quantities are proportional from tables or graphs. All right, have a great day, y'all.